To demonstrate how much effect an environment can have on a material, I will show you a small experiment. A raw egg is put in vinegar of about 9% solution. Leaving it overnight, you can slowly see the eggshell react with the vinegar. If we take the egg out of the vinegar, the hard shell is gone. It reacted with the vinegar. Only the squidgy egg sac and the raw egg inside are still left. So, what does the environment do to aircraft and spacecraft structures and materials? Aircraft and spacecraft operate in many different environments, each of which has its own effects on the materials we use. You can think here of a helicopter operating search and rescue missions over sea, meaning that the air is filled with moisture and salt. Aircraft structures tend to also hold fuel and hydraulic fluids in tanks and aircraft systems, and, as strange as it may seem, every now and then aircraft and spacecraft also need a good clean. So let's zoom in on a helicopter in a saline environment. For most metal alloys, the combination of moisture and salt forms an aggressive environment that leads to corrosion. Corrosion is an electrochemical reaction that metallic atoms have with oxidants and can be accelerated by the presence of water. This makes corrosion a real issue in metals and can lead to disaster, as was the case for the ill-fated Aloha Airlines Flight 243 that lost part of its upper fuselage during the flight. Here, the cause was determined to be a combination of fatigue, due to the many short-distance flights, in combination with crevice corrosion caused by the aircraft operating in a coastal environment. Miraculously, only one person aboard this Boeing 737 died, and the aircraft was able to land safely. As a result of the investigation, structural and material design changes were made to the 737. Other environmental factors to consider, especially in space, are radiation and ultraviolet or UV light exposure, atomic oxygen and vacuum. In the outer atmosphere, free radicals, and especially atomic oxygen, have a large effect on the degradation of materials. Some materials, such as aluminum, erode slowly, others, such as platinum and gold, are highly resistant. Polymers, however, do not do well in this environment and require the application of, for instance, silicon-based coatings to shield them. In vacuum, degassing can be an issue. This is the phenomenon that substances evaporate due to vacuum. Many materials, such as composites, adhesives and polymers, contain substances that can evaporate. Even metals may release gases from cracks or impurities in the metal. This has an effect that, over time, the material properties may deteriorate. The effect of radiation and ultraviolet light can also have a deteriorating effect on materials, especially on natural and synthetic polymers. Take this car, for instance, that has lost its shine by UV radiation of the sun. It is worthwhile to note that Kevlar, such as used in bulletproof vests, and aramide fibers are also sensitive to UV radiation. Aircraft and spacecraft tend to also hold a lot of fuel, as well as oil and other lubricants in the many systems, such as the landing gear. If an aircraft has an integral fuel tank without an additional fuel bag inside, as is the case here for a Hercules C-130 transport aircraft, all joints and connections are sealed air and liquid tight. To avoid the fuel affecting the structure, great care should be taken to ensure that the material is resistant to chemical components of the fuel or that coatings are used. Also, care must be taken that the sealants used do not act as enablers for undesired chemical reactions that may affect the materials. When operating and maintaining aircraft, it is also important to consider the effect of chemicals used. De-icing, which is essential to ensure the aircraft can safely take off, can be done mechanically or thermally, by warming up the propeller for instance, but it's often done using chemicals. The same goes for cleaning aircraft. Using the correct chemicals and applying them correctly is vital for safety. Over time, aircraft will corrode, just like many objects in life. It is important to realize, however, that this process can be slowed down or avoided by picking the right materials. And, to speak with the words of the great Dutch soccer legend Johan Cruyff, every advantage has its disadvantage. Realize there are pros and cons for every material choice or structural solution you choose. For instance, metals are more likely to corrode, but polymers are more susceptible to UV radiation. Before I go, there's one more type of corrosion I'd like to highlight: galvanic corrosion, using a typical Dutch mode of transport, the bicycle. In winters, bikes are exposed to mud, water and road salt. Because the bike wheel is made of different materials, one material corrodes due to its contact with another material or metal, similarly to how batteries work. In our case, the brass spoke nipple reacts with the aluminum rim. This galvanic corrosion is something you should check that it cannot occur in your design. Please realize that it is not limited to metal contact. An electric potential difference can also occur between a metal and another material. If it cannot be avoided, one must try to isolate the materials from each other or avoid the immersion in an electrolyte. Finally, sometimes clever use is made of galvanic corrosion by deliberately placing material in a structure where it is sacrificed to protect another material. Zinc is often used in marine structures, as such to protect steel.